going to do a mini lesson on some of the vocabulary and how to deconstruct a word problem, and then I'll follow it up with some specific examples from the written homework. So I want to start here. I posted this slide already, but this is going to be the foundation really for much of what we do in this class. So if we first talk about a population, so the population is the collection of all the things that we want to learn about or that we're interested in. We're interested in something about the population. And when we're talking about the population and, determining what we're interested in, some numerical characteristic, we are always using Greek letters. Greek letters tell you that we're talking about the population. And when we're talking about some characteristic of the population, we call that a parameter. So that's a general term for any numerical characteristic of a population that we're interested in. And generally, we don't know what the value of that is. All right. The first two parameters we're going to start with are pi, and that when we talk about pi, again, that represents a parameter, meaning we're talking about it's related to the population, and we use pi when we're talking about categorical data. All right, and so the description, the definition of that is the long run proportion of success, and a proportion is a fraction. We'll talk more about that on the next page. When we're talking about a characteristic that is quantitative data, we're talking about, we call that mu. And the symbol for mu is just that little m, and mu is the Greek letter for m. Pi is the Greek letter for p. So these are both Greek letters. Whenever you see a Greek letter, you know that we're talking about some characteristic of the population. Population starts with P, parameter starts with P. Okay, that's one way to remember that. Parameters go with populations. All right, so since we typically don't know the characteristic of the population, sometimes it's really just not feasible to know. Let's say we wanted to know the average weight of all the people in the United States. It's not really feasible for us to go out and weigh every single person in the United States. So what do we do in that case? If we want to find out, we're still interested in the average weight, but it's not feasible to weigh everybody. That's where statistics comes in. So if we're interested in something of the population, what we do is we want to take a sample that represents the population. So we take a subset or a portion of that data. We take a sample, some sample. See here, we selected randomly some elements of the population to form our sample. N is the sample size, the number of things that we select from all the things. And so what we're able to do in that case is that we can study or we can observe some of those elements or units, okay? So we're observing some number, N, or the sample size, some number of elements. And the way that we can distinguish between whether we're talking about the population or the sample is we use Roman letters to represent the characteristic of a sample. Another way that you can help remember is that sample starts with S, and then we call those characteristics statistics. So S and S, when we're talking about statistics, we're always talking about something, some characteristic of the sample. And that numerical characteristic obviously is known because we took a sample, we took some subset of the data, we observed those characteristics, or we calculated that numerical value. It's known to us. So we talked about when we had our population, pi is the symbol when we're talking about categorical data. Whenever we're talking about, so if we're interested in some sort of categorical data in the population, we're going to take a sample and look at that same categorical data in the sample. So when we're talking about a sample, we're talking about p hat. P hat always goes with pi. They both start with p. So the symbol for the statistic when we're talking about categorical data is p hat. That represents the proportion of success from our sample. When we're talking about quantitative data, if we're interested in quantitative data in our population, when we take our sample, we're going to observe that quantitative characteristic in our sample. We call that X bar. Whenever we're interested in quantitative data, for the parameter it's mu, and in the sample it's always called X bar. Mu always goes with X bar, pi always goes with p hat. So for each parameter in a population, when we take our sample, we call it a statistic. Each parameter has a corresponding sample statistic that goes with it. So let's talk a little bit more about statistics and parameters. Again, when we take a sample, we have some finite number of things that we can calculate, we can observe, we can calculate the statistic. It's known. So we can take that sample and then we can calculate or observe that characteristic that we're interested in about the population, and we can use that to make conclusions about the population. When we talk about p hat, again, we said that that is the sample, the symbol for the statistics when it's categorical. It represents a proportion of success that we observe from our sample data. So when we talk about a proportion is a fraction. It has a numerator and a denominator. The numerator is whatever we define as success. So let's say it's you're going to vote for candidate A, yes, means success. Or we could say from the written homework, the bottles coming off the manufacturing line that are broken. If they're broken, we say success is yes. So number of successes, which is a category, yes or no, or some other category, divided by, we always have to tell it we always have to say what the denominator is, because it doesn't have any context unless we say what the denominator is. And when we take our p hat, the denominator is always our sample size, and then our numerator is always the number of things in that category that we define as success. And we use that because we're interested in pi, or the parameter. If we talked about pi, that would be the number of success out of the entire population that we're interested in. But again, that's typically not a reasonable thing to go out and do, or it's just not feasible at all. When we talk about X bar, remember we said that is the statistic when the thing that we're interested in is quantitative, meaning it's data that we can actually do a calculation on. We can calculate the mean or average from that data. So when we take our sample, we take a sample size of some subset of the population. We add up all those quantities, say it's weight of each individual thing, say it's time. We add them all up and we divide by how many things that we sampled. This is X bar. We're doing that because we're interested in mu, the mean or average of all the things in the population. So that parameter would be if we could take all the things, let's say it's the weight of each person in the population divided by the number of people in the population, that would give us the average weight of all the things. When we take our sample, we find the average weight of the sample that we took, and then we try to use that to draw conclusions about the entire population. Here's sort of my cheat sheet for how to deconstruct word problems. And I like to say, when you read a word problem, if you see in the problem that it says you're interested in the average or mean of something, if the answer is yes, then we know that we're talking about mu for our population parameter and X bar for our sample statistic. This is always true. If the thing we're interested in the problem says average or mean, then we're dealing with quantitative data. Otherwise, sometimes it's harder to determine when the problem has categorical data. So I always like students to just ask themselves, does it say mean or average? If so, we know we're dealing with quantitative data, mu's and X bars. Otherwise, we're dealing with categorical data, pi's and p hats. You can read this on your own. This is the chart that I already posted in Lumen. The other thing that I want to point out from this, a lot of times when I'm looking at a word problem, I start with the sample. It's sometimes easier when we're reading a problem to identify what did we sample. Maybe it says we selected something randomly. A lot of times it's easier to distinguish what was our sample size, and then we can work back from there. So the sample is a subset. It's some of the things we're interested in. We could work our way backwards then and say, okay, if that was some of the things, then I can write what the population is by saying, well, that would be all of the things. We took a subset, some of the things. The population is all of the things. And again, if we can determine whether we're dealing with quantitative data from our sample, then we know that that also means that we're interested in quantitative data in our population, which would mean our parameter is mu. If we were interested in, or we took our sample data and we got a proportion, number of success divided by our sample, then that means that we're interested in that same proportion of all our population, or pi. We'll get into standard deviation at some point, but it follows the pattern where whenever we see a Roman letter, that means we're talking about the sample, and it has a corresponding Greek letter that tells us we're talking about the population. The variable is the individual thing from each of the things that we observe. I like to give students a sort of visual with regard to a clipboard. So from our written homework, we had the problem that we were interested in the average price of milk at all gas stations that sell milk. So from there, we took a sample. So let's say we sampled 12 gas stations, and we looked at each gas station we're observing gallon of milk, all right? So we would say, okay, we go to one gas station, we look at 1 gallon of milk, and then our variable would be, if you think of the heading here, when we look at that gallon of milk, what are we interested in? We're interested in the price of each gallon of milk, which we would call X. So maybe at the first gas station, we look at a gallon of milk. Let's say it costs $2.99 a gallon. We go to the second gallon of milk. Maybe that's $3.50 a gallon. Let's say it's $3.50 a gallon. At the next station, maybe it is $3.25 a gallon. So for each gallon of gas, the price varies based on which gas station we're in. This is the variable. The variable is what is the price of each gallon of milk that we're sampling. It's not the average price. The variable is the thing that changes from each thing that we observe, which is the price of each gallon. And then we would say the data is this collection of all, in this case, the 12 gallons of milk that we observed. So how does that translate into an X bar then? Well, our X bar would say we would add up the price of all the gallons, all the X's, we would add them up, and we would divide by how many we sampled. So I sum up all the prices, divide by 12, we calculate our observed X bar. I'm going to pick up the next video with some real examples.